Hey everyone, I want to provide this brief tutorial on how to solve break-even point problems. They come up in Unit 2 in the assignment, and I don't think the explanation in the textbook is quite as clear as it needs to be. So I'm going to show you just two sample problems. I don't think you have any problem solving these. So a break-even point problem, what's going on is it's about purchasing a piece of equipment and how much that machine is going to cost us, and then how much it's going to contribute to our operation over time. So how long is that machine going to take to pay for itself? And we can do that with an individual machine, or we can use it if we're going to compare two machines. So let's take a look here. Here's a basic problem. Bob is considering purchasing a new soft ice cream machine for his food truck. He wants to know how many ice cream cones he would need to sell before the machine will pay for itself. When we see that term pay for itself, it really means break-even point. The cost of the machine is $2,500. We always need to know that. We call that the fixed cost. Those of you in accounting, it should ring very clear with you. The variable cost of each ice cream cone he would sell is 85 cents. So that means for the cone and the wrapper and the mix and whatever it takes to actually make the ice cream, that's going to cost him 85 cents. He would then sell his ice cream cone for $3.50. So we already see he's going to be making some profit on this, which is kind of a good thing. So let's take a look at this. The way the formula works for a break-even point problem is that we take the fixed cost, and actually I'll give this the name of so it's a BE, break-even quantity is what we're looking for. We want to know what the quantity is when this machine will pay for itself. And it's the fixed cost divided by the revenue minus the variable cost. And in this case, we know that the machine's going to cost us $2,500, and we know the revenue is $3.50, and we know that the variable cost, subtract 0.85 cents. So we can do that quick in the calculator. It's 2,500 divided by $2.65. Now this $2.65, we call this the contribution. So how much does each sold ice cream cone contribute to covering the fixed cost of the machine, which are $2,500? If you do that in your calculator, you'll find out that that's 943 ice cream cones. So now Bob needs to answer the question, how many ice cream cones can I sell if I get this machine? And if it's going to take him more than a year to sell 943 ice cream cones, he's probably not going to want to buy this machine. But if by buying this machine he can maybe sell 50 a day, then in a matter of a month he can pay off the entire machine. But knowing what this quantity is tells me whether whether this machine will really be of value to my operation. So this is the one that will work for the problem that I believe you're going to see in Unit 2. But let's look at a second example just in case. In this case, Francisco wants to add a pickleball making machine. So I don't know if you've seen a pickleball, but it's a round ball about 4 inches in diameter. It's plastic and it's full of holes. It looks like a wiffle ball if you've ever used one of those in gym class. So a pickleball making machine to his sports equipment manufacturing plant. There are two leading companies that have machines he could purchase. Machine A costs $30,000, which now immediately you know that's the fixed cost. So let's do this. Fixed cost of machine A, fixed cost of machine A will be $30,000. The variable costs of machine A are going to be 32 cents right here. And then machine B is his other option. So fixed costs of machine B is going to be $25,000, and the variable costs will be 55 cents. And so there's kind of a two-step process we go through here. We're going to set these two equal to each other to see what the break-even point is where it doesn't matter which machine you buy. So we're going to take the fixed cost of A, which is $30,000, plus the variable costs of A, which were 32 cents per ball. And we're just going to put Q in here. Q stands for the quantity of balls we're going to produce. And we're going to try to set this equal to the 25,000 that we pay to buy machine B, plus the variable cost of machine B, which would be 55 cents, and again, times our quantity. So this is where your algebra comes in, and so you know if you subtract 25,000 from both sides, that will move it over here, and we end up with 30,000 minus 25,000. That ends up with $5,000. And now the 32Q is still stuck over here, so we're going to subtract it from both sides, which means it's going to be 5,000 equals 55 cents minus 32 cents, which is going to be 23 cents, 0.23Q. And if you stay with your algebra, we divide both sides by the 23 cents. Divide this side by the 23 cents, just basic algebra. And we find that the Q is equal to, put this in the calculator, 21,739. So that is the point at which these two machines will basically be equal. So if he's going to make less than 21,739 pickleballs, then he's going to go with one of the machines. And if he's going to make more than 21,739, then he's going to go with the other machine. So let's test that. Let's just say that Francisco came up and we're going to choose a number less than 21,000 to check it. We're going to use 20,000. So for machine A, it would be the 30,000. Get those 3 zeros in there, plus the variable costs of 32 cents times, sorry, I ran out of space, the 20,000 balls we're going to produce. And the answer to that is it would cost him to use this machine to make it $36,400. Get that 4 back in there. There we go. That's his cost of machine A. Now we can do the same thing with machine B. Machine B only costs us $25,000, and its variable cost was 55 cents times the 20,000 again. And remember, this is machine B. And if we multiply these all out, we get $36,000. Obviously, a little lower. So, what this tells us is that if he's going to produce less than the break-even point, he should buy machine B because it costs him less money. If he's going to produce more than the 21,739, he should buy machine A. So, little trickier when you're comparing two machines, but try running through that on your own where it's not quite so messy, and I think you'll see how that works.